Jupiter is not what you think it is. We've been staring at this planet for hundreds of years. We've sent spacecraft past it, around it, and even into it. And for most of that time, we assumed we understood what we were looking at. A giant ball of gas, spinning fast, covered in clouds, with that famous storm the size of a planet sitting on its surface. We were wrong, and what NASA found inside Jupiter will genuinely shock you. This isn't about a surface discovery. This isn't about a new moon or a prettier photo. What we're talking about goes all the way down, deep into the interior of the largest planet in our solar system, into a place no human instrument has ever directly reached. And what's hiding there rewrites the story of Jupiter entirely. For decades, we assumed Jupiter had a solid core at its center, a dense, rocky heart surrounded by layers of gas. Simple, neat, easy to put in a textbook. But new data from NASA's Juno mission, a spacecraft that has been orbiting Jupiter and diving closer to it than anything we've ever sent before, that data tells a completely different story. And understanding that story changes what we know about how planets form, including our own. I've been following space exploration for years, tracking every major mission, every data release, every discovery that comes out of NASA and the international astronomy community. And I'll be honest, Juno's findings about Jupiter's interior are among the most surprising things I've encountered. The kind of discovery that makes scientists go back and look at everything they thought they knew. So here's what we're doing today. First, we're going inside Jupiter, past the clouds, through the atmosphere, down into the depths. Second, we're talking about what NASA actually found and why it breaks every model we had. And third, we're going to talk about what this means for Jupiter, for our solar system, and for the search for other worlds like ours. Let's go in. Jupiter is the king of our solar system. It's not just the biggest planet. It's bigger than all the other planets combined. More than 2,300 Earths could fit inside it. If Jupiter were hollow, you could pour the entire Earth into it and still have room. And yet, despite its size, it is made almost entirely of hydrogen and helium, the same stuff stars are made of. In fact, Jupiter is sometimes called a failed star. It has the right ingredients, just not quite enough mass to ignite nuclear fusion and actually become one. So, what's inside? That's the question scientists have been trying to answer for a long time. And for most of that time, the best guess was this: a dense, compact rocky core at the center, surrounded by layers of compressed hydrogen, topped by the thick atmosphere we can see from Earth. Clean, simple, wrong. Here's what Juno found. As the spacecraft made repeated close passes around Jupiter, diving in closer than any probe had gone before, measuring the planet's gravitational field with extraordinary precision, the data didn't match the model. The gravitational readings suggested that Jupiter's interior is far more complex than a layered structure with a solid core at the center. Instead of a compact, dense core, Jupiter appears to have what scientists are now calling a diffuse core, a fuzzy core, a core that isn't sharp or solid at all, but instead is spread out across a huge volume of the planet's interior, blending into the layers above it. We're talking about a core that could extend across roughly half of Jupiter's total diameter. That's enormous. That's not a core in any sense we're used to. That's more like the center of the planet is smeared, mixed in, dissolved into the surrounding material across tens of thousands of kilometers. How does something like that even happen? Here's the leading theory. Scientists believe Jupiter formed early, very early in the history of the solar system. Back when there was still a disk of material swirling around the young sun, Jupiter began gathering mass rapidly, It may have started as a rocky and icy core, growing quickly by pulling in material. But then, somewhere along the way, something hit it. Something enormous. A giant impact. A collision with another large protoplanet in the early solar system. Something roughly 10 times the mass of Earth, slamming into Jupiter at a critical point in its formation. And that collision didn't destroy Jupiter. Jupiter's way too big for that. But it did something remarkable. It shattered and mixed that original solid core, dispersing it, blending it, spreading it throughout the deep interior of the planet, like dropping a sugar cube into a glass of hot liquid. The cube dissolves. It doesn't disappear. The material is still there, but it's no longer a distinct, solid thing. That's Jupiter's core. Dissolved, spread out, fuzzy. Now pause for a second, because I want to ask you something. When you were in school, what did they tell you planets looked like on the inside? Probably layers, right? Like a hard-boiled egg, shell, white, yolk, nice and neat. Drop a comment below. Did your textbook have one of those diagrams? Because it turns out those diagrams might need a serious update. And Jupiter is just the beginning of why. Here's something else Juno discovered that almost nobody talks about. The atmosphere of Jupiter is not a thin skin on the outside. It is deep, shockingly deep. The winds and weather patterns we see on the surface, those massive storm systems, the bands of color, the great red spot, they don't stop at a few kilometers down. They go down roughly 3,000 kilometers into the planet. 3,000 kilometers. For reference, the distance from London to Moscow is about 2,500 kilometers. Jupiter's weather systems are deeper than that. The jet streams that create those iconic bands around the planet are not surface features. They are enormous cylinders of moving atmosphere, thousands of kilometers tall, spinning in parallel around the planet's axis. And beneath all of that, below where the atmosphere ends and the deep interior begins, hydrogen does something you've never seen on Earth. It becomes metallic. Under the extreme pressure deep inside Jupiter, hydrogen, normally a gas, normally the lightest element, gets compressed so tightly that its electrons break free and flow like a metal conducts electricity. It becomes liquid metallic hydrogen, a material that doesn't exist anywhere on Earth's surface. A material that, when it flows, generates Jupiter's massive magnetic field, the strongest planetary magnetic field in the solar system. So powerful it would be visible from Earth if our eyes could see magnetic fields. That's what's spinning around inside Jupiter. Not rock, not solid material. A churning, electrically conducting ocean of metallic hydrogen, generating a magnetic bubble so large it would dwarf the sun if you could see it. We'll get to one more thing in just a moment. Something about what this means for finding life beyond our solar system. But first, stay with me. Here's the payoff. Here's why all of this actually matters beyond being fascinating. Jupiter's story, its fuzzy core, its ancient impact, its impossible interior, tells us something critical about how planets form. Our models of planetary formation assumed that gas giants built up in a certain way, with certain structures, following certain rules. Jupiter just broke those rules. And if Jupiter, right here in our own solar system, can be so fundamentally different from what we expected, what does that say about the thousands of gas giants we're discovering around other stars? We've found planets larger than Jupiter, smaller than Jupiter, closer to their stars, farther away. We've been building models of what those planets might be like on the inside. Now, we know those models might be completely wrong, which means the universe is, once again, more complicated and more interesting than we gave it credit for. So let's land this. Jupiter is not a layered ball of gas with a solid core at the center. It has a fuzzy, diffuse core, possibly the result of a massive collision early in the solar system's history that spreads across half the planet's interior. Its weather systems plunge thousands of kilometers deep, and at its heart, metallic hydrogen flows like a liquid metal, generating a magnetic field that dwarfs everything else in the solar system. This is not the Jupiter they taught you about in school. This is something stranger, more dynamic, and far more interesting. And here's the thing, Juno is still orbiting, still sending data, still making discoveries. The story of what's inside Jupiter is not finished. It's just getting started. If this video gave you something to think about, hit that like button. It genuinely helps this channel reach more people who love this kind of content. And subscribe. Next time, we're going somewhere even more extreme. You'll want to see it. Thanks for watching. The universe is bigger and stranger than you think, and that's exactly why we keep looking.